through, we are going to see what happens when the client connects to the server with default frequency. I have set breakpoints into the code into some strategic places so we can see what happens in the implementation when the connection is done. So I just click the connect button and we meet the first breakpoint here. So you can see that we are now here in the control fragments on click event handler, and the button that was clicked was the connection button, and here we then start looking at what happens. If we return back to the class diagram here, we can see that here the control fragment is using the control interface to make the actual connection. This control interface contains the connect method, which is now used in making the connection. But first we need to know where to connect to, and for that the application needs to access the preferences. So we get the preferences from the storage. This all will be instructed to you on the proper doings, how to do this. So now we just go through what happens here. We get the server's address and port, and we get them from the preferences string, and also get the frequency the user wants to connect to from the preferences. So now we have all that information here ready for making the connection. And as you can see now, we are using this control interface for making that connection. And it's declared here as a member variable of this fragment up here. Okay, so now we are ready to make the actual connection. So we jump in here to the method call. We can see that the model X is actually the class that implements this control interface. As you can see again from the class diagram, model implements the control interface. Okay, basically it just forwards the call to the protocol implementation. So here, and the protocol implementation then actually does all the heavy work. Let's jump in there. Like this. Okay, what happens here is that we store all the variables we got from the parameters at the frequency, and then we start the connection reader and the connection writer objects at this point of time. So again, when you see at the class diagram, we see that the protocol implementation uses the reader and writer to do the actual network connectivity, because these have to be done in secondary threads instead of the main thread, which is a rule that all Android applications must conform to. So we create the connection reader and tell it to start reading. Basically, we just set the running to true and start the thread. So this happens, and the same for the connection writer. Start sending. We put the running to true and start the thread. And basically now the protocol implementation has done its job, and we have executed that user wish to connect to the server. So again, if you will look at this diagram, we see that control fragment asked the model to connect with ask the protocol implementation to connect, and it created these two threads. And the connection reader is now actually doing the job of connecting to the server. So when I now press resume here, we can notice that again here a breakpoint was met. And where we are now, we are in connection reader run. So when we called start, the thread was created, and the run method is now executing this secondary thread code here. And what happens here is that we initialize the connection in this small utility method. We create a new socket object, connect to the server, do some small things like get the input and output stream that we use to actually read and write data to and from the server, set up some variables you need to have in order to implement the actual protocol, and then we change the protocol state to connected. Call that method that we have actually above here. Here we lock the state variable of the protocol, because now we have multiple threads that can manipulate the state, but the manipulation must be always done so that only one thread at a time can change the state of the protocol. So that's why we have to use this lock semaphore to guard access to this state variable, so that only one thread at a time may change these state variables. And then after the lock has been acquired so that this reader thread can safely change the state, it then notifies the main thread using this handler class that it is its job to start doing something. So again, when we return back to the class diagram, we see here that the connection reader is using the handler to notify the protocol implementation, which is running on the main thread side, that it needs to somehow handle this state change of the protocol. So this handler makes sure that the runnable interface of the protocol implementation is called, meaning that the run method of protocol implementation is then called. So now when I resume the application, we can see that now we are in the protocol implementation's run method. So the reader thread told to the protocol that now you should somehow handle this state change. Here the protocol implementation then checks that what is the next state we should switch to, and it is now connected. It does all the necessary things, like releases the lock. Now it's safe to release the lock because the state change has been now handled. And then it notifies the listener that now something happened in the protocol, something changed here. Again, when we return to the class diagram, you see that protocol implementation uses this listener interface to notify changes in the protocol state. And model then handles this notification. Again, when we resume the execution of the application, we notice that now the model's on event is then called, because this is the implementation of that listener interface. And now the model can notify all its observers that something has changed in the protocol state. The observers are the views, and if you have implemented some of these optional listeners or observers of the model, like this is making beeping sounds when signals happen in the protocol, this tries to translate the signals into Morse code and so on. Anyways, all these observers are now notified that something happened, something changed here. And what happens, for example, in the control fragment update method, which is now then called because of this observer method, we can see again when we resume the application that if later on, not now yet, but later on, that the observer is updating the state of the protocol in the user interface. But we didn't go there now. Why? Because the reader thread continued running. And if you read the protocol specifications, it always sends the default frequency when the connection has been made immediately to the client, which is -1. So that's why the connection reader run now continued ahead from the read loop. The read loop here tries to read information from the network input stream. This call actually blocked when the connection was made because there was no data yet coming. But soon, almost immediately, when the server noticed that, okay, now it has a new connection, it sent the default frequency to the client, and that's why we are here. But if you see here below, you can also see that in the main thread, a breakpoint was met. So let's switch to that one. Okay, so now we are here in the control fragment update. So now that observer design pattern notification reached actually the control fragment view, and it can now display a toast that we are now actually connected, and because that's the actual event that we got here, and also it updates the view. This mainly just updates the buttons to reflect the new state of the application. We don't have to go there to see what happens there. So again, now we can resume the program, or we could switch to the thread running here actually. So as you see, I can switch between different threads using this area in the debugger. So we can now see what actually happens here when we got the default frequency from the server. So we read the 4 bytes the server sent us, and we check what was the value we got. From there, it was -1. So the server is behaving according to the protocol. So what we do is that we check the value. It is not greater than 0, but it was less than. So we are now changing the protocol state to line down, because this loop here has been implemented according to the protocol steps. So it or protocol specifications, it knows that now at this point, when we are reading data here, the state must be so that line down is happening next. Okay, so again we resume the application, and again resume the application, and now we notice that we are again in the protocol implementation run, because the reader thread said us to change the state to line down. What happens here is that we lock is again released, and then we notice that the current frequency is -1 because the user hadn't changed the default frequency to anything else, and the message from the server is also -1, so we don't need to change the frequency. Again, then we tell to the listener that, okay, now we have changed the frequency. So we resume the application here again, and the model then, who is the listener, again notifies the observers that now we are again in a change situation. First we connected, and now we have changed the frequency. Again, then the observers get notified. As an example here, the control fragment handles this information so that it just shows a toast message again to the user that, okay, now we are in this new frequency. So now we have connected to the server with the default frequency, which was the purpose of this code walkthrough, to demonstrate how all this happens using these different threads in the application. So important thing here is that you notice that these user interface events result in a method called here in the control interface, which was forwarded to the protocol implementation, which started the reader and writer threads. And then when a state change happens here, the reader notifies the protocol implementation using this handler, and then this notifies the model who listens to the protocol changes, which uses the observer design pattern to notify all the different observers of the model that something changed. Why this handler thing here? It is used to change the context of code execution from the secondary thread to the main thread. That is another rule of Android. If we would directly from here call methods of protocol implementation and protocol listener perhaps to notify about these state changes, then this call, for example, from here to here directly, it would have been done in the context of the secondary thread. And what happens here, again, when the call goes forward up to the control fragment where we update the user interface, that user interface update also would happen in the context of this secondary thread. And that is, again, something that Android doesn't allow you to do. If you try to call methods that change the state of the user interface from a secondary thread, your application will be crashed for breaking this rule. User interface must always be updated from the main thread only. So we have to change the context of that execution to the main thread using this handler post, which notifies this protocol implementation that, okay, now you have to call, or this run method has to be called in the main thread context, and from there you start this notification chain, so that then the control fragment that does the updating of the user interface does it in the context of the main thread. So that is the reason for this handler runnable thing here. Okay, so this is how the connection now has been made. Later on, we will see what happens when user has originally selected a different frequency and we make the connection, what happens in that scenario. But that was the code walkthrough this time.